Hello students, welcome all of you. Today we are going to start the next topic, that is Ohm's law. Let's consider the statement of Ohm's law is it stated that as long as the physical state of conductor remains same. Now what are the physical state of conductor? Length of conductor, temperature of conductor, density of conductor, etc. As long as the physical state of conductor remains same, then the current flowing through conductor is directly proportional to the potential difference applied across it. Mathematically, we can write it as the current flowing through conductor I is directly proportional to the potential difference applied across it. Therefore, we can write this as the voltage or potential difference applied across the conductor is directly proportional to the current flowing through conductor. Now we have to remove this proportionality sign. Therefore, we can write V is equal to, when we want to remove this proportionality sign, we have to insert the proportionality constant. Here the proportionality constant is capital R into I. Therefore, V is equal to capital R into I, where V is the potential difference applied across the conductor, I is the current flowing through that conductor. Then this capital R or proportionality constant capital R is known as resistance of conductor. Resistance of that conductor. Therefore, we can write resistance of conductor capital R is equal to, here capital I in this side multiplied to capital R, on that side it becomes divided to P. Therefore, capital R is equal to, we can write V divided by capital I. Therefore, we can also say that the ratio of potential difference to the current flowing through conductor is always remains constant. That constant is known as resistance of that conductor. Here the SI unit of resistance is ohm. Ohm is equal to SI unit of potential difference is volt divided by SI unit of current is ampere. Therefore, we can write 1 ohm is equal to 1 volt divided by 1 ampere. Therefore, from this equation, we can define 1 ohm resistance as, if the potential difference applied across the conductor is 1 volt and the current flowing through that conductor is 1 ampere, then we can say that the resistance of that conductor is 1 ohm. Now, from this equation, we can also write as I is equal to voltage divided by resistance. Therefore, we can write first, the current flowing through conductor is directly proportional to the voltage or potential difference applied across the conductor, or second, we can write the current flowing through conductor is inversely proportional to the resistance of that conductor. Now, what is the resistance then? What is the resistance? Resistance capital R is nothing but the opposition to flow of electrons. Now, when we connect a conductor across a battery, that is, when we apply a potential difference across this conductor, then in that case electron flows from negative terminal of battery to the positive terminal of battery. In that case, we can say that current flows from positive terminal of battery to the negative terminal of battery. In this way, the direction of current from positive terminal to the negative terminal of battery, whereas the direction of electron is from negative terminal of battery to the positive terminal of battery. Now, the current flowing through conductor is nothing but rate of flow of electron through that conductor. As the number of electrons flowing through conductor increases, then the current flowing through that conductor increases. But the resistance is nothing but opposition to flow of electrons through that conductor. Resistance opposes to flow of electron. रेजिस्टेंस क्या करेगा? वो इलेक्ट्रॉन को कंडक्टर में से जाने के लिए क्या करेगा? उसको अपोज करेगा, वो उनको स्टॉप करेगा. नाउ as the opposition to flow of electron increases, the resistance of that conductor goes on increasing. Now the resistance of conductor is given as R is equal to voltage divided by current. Now how this resistance produces in that conductor? We know that there are large number of free electrons in that conductor. When we connect that conductor across a battery, then the electron flows through that conductor. Now during that flow of electrons through that conductor, they collide on the positive atoms of that conductor. जब इलेक्ट्रॉन कंडक्टर में से जा रहे हुए उस टाइम वो क्या करेंगे? इलेक्ट्रॉन को तो आंखें नहीं है. जब इलेक्ट्रॉन कंडक्टर में से फ्लो करेंगे तो जाते टाइम वो बीच में जो पॉजिटिव एटम्स होंगे उस पॉजिटिव एटम पे जाके वो कोलाइड करेगा, स्ट्राइक करेगा, फिर से वो उसका डायरेक्शन चेंज करेगा, फिर आगे चलेगा, फिर वो नेक्स्ट एटम पे जाके क्या होगा? स्ट्राइक होगा, कोलाइड होगा. नाउ इफ देयर इज अ लार्ज नंबर ऑफ कोलिजन, देन वी कैन से दैट जिस कंडक्टर में कोलिजन ज्यादा होगा उस कंडक्टर का रेजिस्टेंस ज्यादा होगा, जिस कंडक्टर में कोलिजन कम होगा उस कंडक्टर का रेजिस्टेंस कम होगा. फॉर एग्जांपल इफ यू कंसीडर आयरन रॉड और सिल्वर रॉड or aluminum or copper rod, then the resistance of iron is greater than the resistance of copper, because when the electron flows through the iron rod, जब फेरस और लोखंड के रॉड में से जब इलेक्ट्रॉन फ्लो होंगे तो वहां पे कोलिजन ज्यादा होगा एज कंपेयर टू द कॉपर. कॉपर के रॉड में से इलेक्ट्रॉन जब फ्लो होंगे तो वहां पे कोलिजन कम होगा. दैट मीन्स द रेजिस्टेंस ऑफ कॉपर मटेरियल इज लोअर देन रेजिस्टेंस ऑफ आयरन मटेरियल. The resistance of that material depends on how compactly that material is packed, or how compactly the atoms are packed inside that conductor. Now the resistance of conductor is given as R is equal to voltage divided by current flowing through that conductor, or we can say that resistance is nothing but the ratio of potential difference applied across the conductor to the current flowing through that conductor. We have also discussed the 1 ohm resistance. 1 ohm resistance is the resistance of conductor when the 1 volt potential difference applied across the conductor produces 1 ampere current flowing through that conductor. Then we can say that the resistance of that conductor is 1 ohm. Now next we are going to discuss the IV characteristics, voltage current characteristics or voltage current graph. According to Ohm's law, we know that current flowing through conductor is directly proportional to the potential difference applied across it. Then when we plot it on a graph, let's consider on the x-axis there is voltage or potential difference, and on the y-axis there is current. On the x-axis we have to consider the independent quantity, while on the y-axis we have to consider the dependent quantity. That is, here we are going to change the voltage and the corresponding current changes flowing through that conductor. हम यहाँ पे क्या करने वाले हैं? Voltage step by step from 0 to next level. We are going to increase the voltage in step by step, and we are going to note down the corresponding current. Then when we plot these values on the xy coordinate or on the graph paper, we will get a straight line passing through origin. Now this indicates that as we increase the voltage, the value of or current flowing through current also goes on increasing. Now when the voltage or potential difference applied across the conductor is 0, then the current flowing through that conductor is also 0. The experimental verification of Ohm's law. For experimental verification of Ohm's law, we require the electric component as battery, switch, conducting wires, resistance, ammeter, voltmeter and rheostat, which are connected as like this. Here is the battery having positive and negative terminal. Then next is plug key. Now the positive terminal of battery is connected to the ammeter, which gives the current or which measure the current flowing through that conductor. Then ammeter is always connected in series with the circuit. Then next is the resistance. Now the voltmeter is always connected in parallel with the resistance. Here is the positive and negative terminal of voltmeter. Now here is the rheostat is used to change or to maintain the amount of current flowing through conductor, flowing through that circuit. And here is the variable terminal of that rheostat, RH. Here is the key K. Now from this circuit, first we have to maintain the rheostat at its higher value such so that the small amount of current flows through that circuit. Now first we have to note down the small amount of current flowing through that circuit and the potential difference applied across the resistance. Now first we have to note down observations number, voltage and current. Now we have to note down the first voltage and current. Now next यहाँ पे क्या करना है हमें, पहले बैटरी यहाँ पे हमने क्या किया है, बैटरी का पॉजिटिव टर्मिनल एमीटर के पॉजिटिव टर्मिनल से कनेक्ट किया है. देन एमीटर का नेगेटिव टर्मिनल कनेक्टेड टू द रेजिस्टेंस. रेजिस्टेंस का नेक्स्ट टर्मिनल हमने रेओस्टेट के वेरिएबल टर्मिनल से कनेक्ट किया है. रेओस्टेट का एक टर्मिनल हमने प्लग के थ्रू से बैटरी के नेगेटिव टर्मिनल को कनेक्ट किया है. अब इनिशियली रेओस्टेट की वैल्यू जो स्लाइडिंग कांटेक्ट होता है उससे हमें वो मैक्सिमम लेवल पे फिक्स करना है सो दैट वेरी स्मॉल अमाउंट ऑफ करंट फ्लोज थ्रू दैट सर्किट. इन दैट केस वी हैव टू नोट डाउन द वैल्यूज ऑफ करंट एंड वोल्टेज. हम यहाँ पे वोल्टेज की फर्स्ट वैल्यू और करंट की वैल्यू लिखेंगे. बाद में हमें रेओस्टेट का जो कॉन्टैक्ट स्लाइडिंग कॉन्टैक्ट होगा उसे स्लाइड करना है रेओस्टेट पे सो दैट द करंट फ्लोइंग थ्रू सर्किट गोज ऑन इंक्रीजिंग. जैसे हम स्लाइड करेंगे वैसे करंट क्या होगा, इंक्रीज होगा. एंड द पोटेंशियल डिफरेंस अप्लाइड अक्रॉस द रेजिस्टेंस आल्सो गोज ऑन इंक्रीजिंग. देन अगेन वी हैव टू नोट डाउन द सेकंड रीडिंग वोल्टेज एंड करंट. V1 here I1, V2 I2. Similarly, by adjusting that rheostat at different points, we have to measure the current and voltage, corresponding current and voltage. Now we get the number of readings V3 and I3. Now when we calculate the ratio of voltage divided by current, we can found that this ratios V1 divided by I1, V2 divided by I2, V3 divided by I3 always remains constant. That constant ratio is nothing but the resistance connected in that circuit, which is in ohm. Now from this experiment we can demonstrate or we can verify the Ohm's law, as well as this experiment is also used to find out the unknown value of this resistance by taking the number of readings. And when we take the ratios of voltage versus voltage and current, we will get the unknown value of that resistance.